Hello and welcome to Eddy. So, have you ever wondered why transformers, motors, and even some induction cooktops get warm when you use them? Or how we can detect cracks in metal parts without even touching them? Well, all of this is connected to a fascinating phenomenon called eddy currents. So, let's understand what eddy currents are. What exactly are eddy currents and how are they created in a conductor? Let's start with the basics. Imagine you have a metal plate like a conductor placed near a magnet. Here N is the North Pole and S is the South Pole. If that magnetic field starts changing, either by moving the magnet or by increasing or decreasing its intensity, a curious thing happens inside the metal. Small currents begin to swirl around in loops. These swirling currents are what we call eddy currents. So, to understand eddy currents fully, we need to talk about two things: magnetic field and electromagnetic induction. So, here's a question to consider: what happens when a magnetic field near a conductor changes? So, when there is a changing magnetic field close to a conductor, it creates a type of current inside the conductor. But there's an interesting part: the eddy current that forms always tries to oppose the change that is created. This follows something called as Lenz's law. So think of it as nature's way of resisting certain changes. So why do you think these currents flow in loops? It's because they need to close themselves to form a complete pathway. So picture like little circular paths inside. Let me draw one. So these are the little circular currents inside the conductor, all rotating in closed loops, like kind of whirlpools in water. And these loops formed in plane that are perpendicular or at right angle to the magnetic field. Now here's an interesting question. Why do eddy current matter? Well, they actually have a big impact. Eddy currents can cause loss in energy. In devices like transformers, induction, cookers, and motors, eddy current can cause energy loss. So when eddy currents flow, they create heat, and that heat can mean energy lost from a device. So think about it. More energy lost to heat means less efficiency, right? So what's one major drawback of eddy current? Yes, you guessed it right. Energy loss. But this is not always a bad thing. In fact, that heating effect of eddy current is useful in certain cases, like in induction heating furnaces. These furnaces use that eddy current to heat metal, which can be incredibly useful for melting or shaping metal. So sometimes that lost energy is exactly what we want. So eddy current also has so many other applications. Like eddy currents are also super helpful in technology like metal detectors and for inspecting metal parts for cracks or flaws. How? Well, imagine eddy currents flowing smoothly through a metal plate. If there's a crack or some other flaw, the eddy current get disturbed, revealing the flaw without any direct contact. Pretty interesting, right? Now, can anyone guess what would happen to eddy current if we use thicker conductor? Yes, currents would become stronger, which would cause increased energy, both losing and heating. So let's recap. Eddy currents are loops of electric current generated inside the conductors when there is a changing magnetic field. They oppose the change that causes them, following Lenz's law, and they can lead to energy loss due to heating. But they are also incredibly useful in applications like detection of crack. And now that you know about eddy currents, where do you think you might see them in action? Think about it. Thank you.